All right, welcome back. We're finally getting into the Jawbreaker amp here, doing some repairs. I've got a big box of parts to put into this guy. I think we're going to, even though it'll take a little bit more prep work up front, I'm going to desolder all of the wires connecting these boards and then just do these circuit boards one at a time, basically go through and do a full rebuild, test components as they're coming out, to see if we can find what actually failed, but then also just do an overhaul on this amp to get it up and running. We're going to start with this board here. I'm going to go through and label all of these wires so that I know where they go back when we put it back together. And then I'm going to replace the filter caps and these two small capacitors. I have these transistors. I need to get some heatsink compound before I change these, some thermal compound to go underneath there. And we will go from there. If we have time, we'll dive into the secondary bottom board, but that may end up having to be a second video. This is going to be a little bit of a time-consuming process. Let's see how far we get tonight. Okay, so you can see this is the type of thing I'm talking about, basically numbering all of the wires, making a note of which color they are, and then I'm going to go through some painter's tape and then just wrap around each of these wires with the same number so that I can easily put this back together, even if it sits for a while and I don't remember exactly where everything goes. Okay, so now that everything's labeled, I can go ahead and disconnect these wires so that I can isolate the circuit board. These two black wires are actually just going from the rectifier right to the PCB, so I won't need to disconnect those. Oh, and I just saw I missed two other guys down here though, so I will need to label those guys up. Okay, this will maybe be a little bit clumsy with the camera angles, but I'll do my best to show you guys what's going on here. Basically need to heat up these wires and then just pull them out from the other side. There's that guy. We'll be able to clean up these solder joints once everything's disconnected. We have the board isolated. All right, so here's our power board. Essentially what's going on here, this is the power supply of the guitar amp. So 120 volts is coming in from the wall, and it is being turned into two separate DC voltages via these rectifiers. These just take that AC voltage and turn it into DC. So alternating current to direct current. We then are going to go through filtering. So these capacitors act as ways to smooth out any ripple that's left over from that conversion. These are going to act as, these two are going to be setting our voltages that are then going out. So these are voltage regulators. In conjunction with these guys, we then have a Zener diode. I believe these two little guys here are Zeners, which are then going to also act as a way to set a static output voltage that then goes on to the rest of the amp. So these are one of the most common things to fail in a guitar amp just over time. In the message that we got, we had been told that these had been replaced at some point, but it is a pretty common service point of a guitar amp, so I'm just going to go ahead and change these out. They have a fluid inside of them, a dielectric fluid that dries out over time, and can cause an amp to fail, and then you'll get ripple in your power supply. That's when you start to hear hum coming through and things like that. So we're just going to go ahead and change these out while we're in here. I'm also going to change out the small guys. I also ordered these transistors to replace and the Zener diodes. We'll see if it needs them. But at this point, we're just going to start with the caps. Okay, so I've made notes for myself about which side is positive and which is negative. You can see there's a negative sign here that then points in a direction. So these three, negative is over here. These three, negative is down here. And then same here, we have 2 with negative on this side, 2 with negative on this side. This way I can't mess it up when I put in the new guys. If we do that, these will blow up. So want to get it right. Okay, now we've got a much cleaner board to work with. You can see there's some silicone there that was used to secure those caps in place, so I'm going to need to use a little razor blade to kind of clean that up so we can apply our own version of that. You need to do that on these amps to make sure that they are supported by something other than just the legs that are soldered in place. These are heavy enough that they're going to vibrate in the amp and they can break their solder joints if they're only supported by those joints. So we use something like this to secure them in place. Okay, I'll go ahead and remove the excess solder from all these points, and then we will look at installing. I may test a couple of these other components while we're here, and then we'll look at installing the new capacitors. So while we're here, we can test the rectifiers to make sure that these weren't the issue. I would be very surprised if they were, but they're basically a series of diodes, so 4 diodes that are in a diamond configuration. So we can go to our diode checker, and we don't even really need to know which polarity it is. We just need to see, so there's a good diode. That's the forward voltage of the diode turning on. And let's see if we go from there to here. There's another good diode. From this one to this one, that's also good. Okay, so all 4 of these ones are good. We can do the same here, it's just these are the 4 legs. That guy's good. That one's good. That one's good. And that one is also good. Okay, so both of these components we know are good. They did not cause the problem for what we are seeing in this amp. I also, while we're in here, just without even knowing what these resistor values are, we can just make sure that they're not failed open or not failed short. Again, we could compare these against the schematic, but really we just need to see that there's something there that's some kind of reasonable value for a power supply. And then this guy. Okay. Now the rest of these components, these and these transistors, we cannot, and these Zener diodes, we cannot reasonably test without applying power. So really, they're only a couple bucks for all those parts. I'm probably just going to go ahead and replace them. I think I'm going to wait till I can get some thermal compound so that I can put these in correctly, clean up the space that's there, and then apply a new thermal compound, just like you would if you were building a computer for your processor, to make sure that there's a good bond between the back shell of these components, of these transistors, that acts as a heat sink that then attaches to this larger heat sink to help dissipate extra energy, because these are basically dropping a larger voltage down to a smaller voltage, and that energy has to go somewhere, so it basically dissipates across this. If it was left to dissipate on the single component, it would end up burning out. Okay, let's clean up some of the silicone that's on here, and then I'll start putting the new caps in. Then we may have to wait until we can get the new thermal compound to do these components. Okay, so to clean this up, we basically just take an X-Acto blade and give a real gentle sideways cut. We basically just want to get as much of this off there as possible so that we have a nice flat bonding surface for the new silicone to go in place. And it's going to be a little tedious and time consuming, so I'll probably speed this up. All right, so we've got most of the silicone off. You can still see a little glimmer on there, but we could spend all night making this perfect. And perfect is the enemy of good. This is definitely enough for us to grab a good surface. So I'm going to clean up the solder joints from where we removed capacitors and wires, and then we will go ahead and put the new caps on. So the reason I went through and cleaned all the excess solder out of those points is to not only have a clear access point for when we're putting the legs through. If there was solder still left in one of those holes, we might not be able to push the component leg through cleanly. But also, if whoever did this job last used a different mixture of solder than we are going to use, if they were using unleaded solder and I'm using leaded, we're not going to get as good of a bond as we otherwise would, since those are going to have different melting points. Now I am going to, it looks like we have some either burned flux or something there, so I'm going to grab some isopropyl alcohol and let this soak for a few minutes, try to clean up some of these other joints on the other side. Okay, we're just going to let that soak for a few minutes, and then I'll give it a good wipe down any excess that's left. Get the brush hairs off from this guy. And then we'll look at installing the filter capacitors back in. Okay, so now we're going to get the new capacitors put in place. Got some silicone RTV. This stuff is high temperature, so it'll be totally fine in this application. I'm going to go ahead and get the capacitors put in place all the way across the board, referencing my diagram that I made, that I added positive and negative polarities to. And then we'll flip it over and just solder everything all at once. Okay, our capacitors are now in place. Now what I'm going to do is create a small physical connection to ensure we're not relying solely on the silicone and the solder joint. So I'm just folding these over, and we're going to clip the legs pretty close to where they land. Now I'm also being conscious of not, I don't want to bend this leg over towards this point where it's going to short out. We kind of want to be in the same plane as whatever trace we are connected to. And I'm also holding the capacitor up against the circuit board from the other side as I'm doing this. And this creates a situation where there will be both a mechanical connection along with the silicone, but we'll clip these short enough that it's not hard for a future technician to remove them. It just needs to be enough to have some grab. And by clipping these before we do the soldering, we prevent any strain on the solder joint from the action of clipping that lead. This does open up the opportunity, though, to miss one of these. So if you're doing this, always make sure that you either count or closely inspect your circuit board to ensure that you didn't miss a lead. Okay, so let's go ahead and solder up these capacitors. Okay. So our new capacitors are in place. We could even put some silicone between these junction points. I'll probably do that once these settle. At this point, we're going to let this board cure. We're going to order some new thermal paste or thermal compound for replacing those. And we may then just have to save the rest of the repair. We're finishing this board real quick and then moving on to the other board for the next week. I'll see how quick I can get this thermal compound in. If the video ends here, it means I couldn't get any before this video goes up on Friday. Otherwise, ignore this because we're coming right back. If that's not the case, though, thanks for watching, and we will be making more progress on this in the next week. Hopefully getting it to a point we can fire up and get a sound test. All right, as always, thanks for watching.